So in ICE there are hundreds of nodes, and these ICE nodes are kept here in the preset manager. You can turn the preset manager on and off using this little arrow here to give you more space. As I mentioned earlier, there's both tools that are simple nodes mostly, and tasks that are presets of compounds. These consist of several nodes put together, and you can see a lot of these nodes. If I get point position, it's a simple compound that gets the self point position. You can delete that by, you can always tell if it's a compound by the double lines around it. So pretty much all of these here are compounds. If you go to tools, these are mostly just single compiled nodes. And there's all different nodes here. You can search for them using the search tab. So if you're looking for something to randomize, you can type RAND, and you can find like a randomize. This is both looking at both tasks and tools. So you can look at any of these ones here. You can clear with C right there. So if we look at again tools, we can say there's a push for array tools. You can see them by category: array, color, comment, constant. These are different number types. Conversion, converting number types. Data access for getting and setting things within your scene. Debugging. Execution. So the execute, there's filters, there's ifs, there's your loop. Geometry queries, where you can get different information from geometry. Math nodes. These are really powerful nodes we use a lot in most ICE trees to create the effect you want. There's even your dot product, and so lots of different math nodes: basic, comparison, logic, matrix maths, statistics, trigonometry, your cos and sin. Vector, here's where you'll see the dot product and cross product, very useful ones for getting angles. Point cloud for getting and adding and removing and deleting points on a point cloud, very important for particle systems. Rotation and simulation, both standard particle simulation and a rigid body particle simulation. So those are where your tools are located. Most of the time I use a search. Normally I may start by looking at categories and then using search. Say you don't know what one of these nodes does. Say you say, okay, I want to be working with some sort of geometry node. So you'll get a geometry query, and you say I want to use this closest point. I don't really know what that does. Double click on the node, click on the question mark, this one here, and it'll open up the documentation for the get closest points and tell you what it does. So if you're not sure about a node, there's one way to look at documentation. The question mark up here again will work, and that's a quick way of finding out about a node. Group geometry, what's that one do? Again, double click on it. If it has no property, you can also, that should do something. That one has no property window, so again it doesn't tell you too much. If it has a property window, you can double click and click on the question mark to get information on the node you want. You can also just look at the search here. This is your ICE reference, and you can also just search for a node inside here as well. So again, it's a great way. If you want to learn more about ICE, I also recommend looking at some of the nodes you have under the Task tab. You say, oh, I want to find out how a turbolize works. Well, open up the turbolize, click on the E, and you can see what it does. It adds something, it multiplies. We can read these nodes node by node, and you normally read them across. So what's happening here is getting a particle position, that's same as a point position, and it's adding two values together. Plus, you can see there's some more values coming in from the outside. This value is a turbolize center. It's using the turbulence node, feeding that point in, and then multiplying by a variance and adding the base value. Inside here is taking, you can see 2 comments, you can frame those. We can move the center over time. This is probably to deal with the animate function. And then we can also expose uniform spatial frequency. Don't know exactly what that does, but it says here invertible numbers over bigger numbers equal bigger spaces between the peaks and troughs. So, and that's going into space frequency. This number here is going into the position. You can see it's dealing with the position, and you're taking the current time, negating it, multiplying by scalar. Time varying goes in here. The add, you can just see exactly it's adding the time to the position. So that's roughly what it does. You can see inside this node and get an idea how this node works. Sometimes the node won't do exactly what you want. You may be using one of these tasks. For instance, you can see here closest point. Let's go closest location. That's not the one I want. Closest location on geometry. You can take one of these and say, oh, I want to go in here and see what it does. Open this up, see how it works. So we don't want the found to be output as well. We can take the found and output that, so the found position to also output. So we've changed one of the factory compounds to give it one more output that we wanted. So feel free to go in, look at these nodes, and look at the compounds to see how nodes were used in different situations. Also, a great way to work is look under User Tools, Browse Examples. There's a bunch of examples here, and you can look at these examples and say, hey, am I building something like one of these? And you can see lots of examples. You can see here a simple push with weight map or push with texture map. We can open one of these scenes up. Push is a great simple one to start with. And you'll see exactly how that one works. If you give it a second. And here's your push weight map. Pick the object. Refresh it, and you can see brings in the weight map, multiplies the weight map by the point normal, adds the point normal to the point position, sets the point position, and creates this kind of effect. Now I say, oh, this is kind of cool. It's got a multiple value here, and of course I can increase the value here to increase the amount of weight, and that's what that multiply here is by. So great tool you can work with. You can make this into a compound if you want. Let's have a look at a few more examples. Here on the browse examples. Some are a lot more complex. Like here's a bidirectional deformation. If I open this one up, just drag and drop it in my scene. There's a lot more complicated one. This is a simulated ice tree, and actually I use this one as a basis of one of the examples I'm going to build later on. But you can see here it's animated, and it's actually a bidirectional deformation. Let's go into shaded mode, and you can see, turn the grid off, and see how that one is working. It's actually a really cool kind of deformer we can use. Again, you can look at some of these objects, refresh it, and see what the ice is using. This dent deformer. The dent deformer uses a raycast. The raycast is also a compound. The raycast is using the raycast node and getting some positions, getting distances between, setting some values, so using those values later on to calculate the bulge and apply deformation. Apply deformation is a bit like the push deformer, getting a normal and a point position and adding and multiplying with lots of nodes. So often it's using fairly simple nodes. There's an if statement in here as well, do a test. But it's amazing with a bunch of adds, multiplies, ifs, you can create something extremely effective and some really cool effects that would be otherwise extremely hard to create. So look at the nodes, look at the examples. It takes some time to get used to how you're going to link everything together, but once you get the idea, ice is extremely powerful. And again, always remember it's mostly point based, so you're normally working with point position or points or normals or particle position. Particle position and point position is all the same thing. You can get kinematic data, as you can see here. We've got the kinematic data, that's the position of the object, but you can't set the kinematic data unless you turn on a special custom variable, environment variable, and that's currently unsupported in X5 version 7.